All right, and welcome back. This is Conway's Game of Life Part 2. We're going to be using the code we wrote in Part 1 as a basis for Part 2. And largely today is going to be cleanup and organizational work. So let's go ahead and get started. We'll jump straight into the terminal. We're just going to start by copying this existing directory into a new directory. So cp-r, our Conway's Game of Life Part 1 directory. And today is the 12th of September, 2025. This is episode 0x202, part 2, Conway's Game of Life. All right. So we're all set in here, but there's one thing that I want to do right out of the gate. I was thinking about it. I was thinking ahead a little bit. I'm going to cd into our new directory. And most of the code that's in this main file currently is actually going to end up being its own class. I'm just going to rename this file. And since it's going to contain the code for our world from part 1, let's just name this file world.py. Then we'll create a new main.py. So touch main.py. All right, let's hop into VS Code now, and we'll close out the code for part 1, and we'll pull up the code for part 2. And the first thing that we want to do is go ahead and get our boilerplate code out of the way. So let's say def main, and just for now we'll say pass. It's if name equals main, then we'll call main. All right, and if you're not familiar with what's happening here, let's go ahead and jump back into the code for part 1, and I'll demonstrate exactly what happens. And we actually used this to our advantage in part 1. So let's cd to part 1, and we'll fire up Python here. And within Python, we will, from main, import world, which is our variable name, right? And that actually ended up executing the code, didn't it? And if we go ahead and look at part 1, we will see that there's nothing preventing the execution. So effectively what is happening here, it's evaluating whether or not if this is the main execution thread, and if so, that's why it's literally called main. If so, we'll go ahead and execute code. If some other process is importing code out of here, this prevents this code from being executed. Hopefully that made sense. But with the basics out of the way, let's move on to our world.py. So the first thing I want to do in this file is define a class. So we're going to say class, and we're going to call it world, typo, capital W, just to conform with PEP 8 standards. That inherits from the base type object. And we'll go ahead and indent all of this code here. Now, the next thing we need to do is define the initialization method for our class. And all that code is the code that's actually down here. So let's first define our method, and then we'll move this code up into the method. So we're going to say def init. And for now, we want to pass in our self. And for the moment, we'll say pass, just so that the IDE isn't screaming at us about syntax errors. Now, print world. Now that it's part of the class, it also needs to take in self, so we'll add self here. And the same is true with get neighbors. So let's add self here. All right. We'll go ahead and take all of our initialization code and move that up into our init method. Let's see, we don't want the while loop. Yes, so this is what initializes everything. Bring it up here into the init. Fix our indentation. There we go. Before I go any further, I want to make sure that my formatting is correct. So let's jump into our shell again and use the black tool again. And now we've got more than one Python file, so let's just say asterisk.py. All right, now that main is external to our class, we want to make sure that our world is configurable from where we're going to be calling it from, the main method. So let's go ahead and add some parameters like rows and columns into our initialization method. And we're actually going to default these to where they're at currently. So 24 columns. Oh, should be an 8. And I think that I also want to make our density of our initialization configurable. So let's add that up here as well. I was pretty happy with how 15 looked, so we'll keep 15. Our world should now be self.world, so it's accessible throughout the entire class. And let's go ahead and add that same keyword into these variables that are going to be used and referenced throughout the rest of the class. And we'll initialize them to what the user passed in, so self.rows equals rows and self.columns equals columns. And we need to fix the references to the world here as well. So self. All right, did we miss anything? I don't think we did. Now there's one more thing we have to do before we can test our new class in main, and that's actually getting this logic inside of its own method. So let's we're going to move the while true loop, the infinite loop, over into main.py. So let's just go ahead and say, delete this out and say def, and let's call this tech. Let's call this step. And, you know, for every time we step through the loop, we'll call this function and step through this code as well. So step, self, and this should have access to everything inside of the class that it needs. Don't forget a colon here. So let's say self.print world, and just for now, we'll say self.world. We'll be improving that in a moment. And this will be self.getNeighbors. And we fix this to self.world. Oh, and I missed this up here as well. Self.world there. And because we're moving our loop logic, we also should remove this sleep. So we can go up to the top here and also remove this import now that it is unused. All right, so let's go ahead and import our new class into our main method and see if it works. So from world import world, and inside of our main we will instantiate world, and I am going to go ahead and just keep it named world, and this might look like we've got a naming conflict here, but Python is really only pulling in this capital W world. It's not actually pulling in the whole file of world. It's just pulling in the individual class because of how we've imported it here. So it looks like a name conflict, but Python will be happy with this. So let's instantiate world, and we'll just go ahead and accept the defaults for now, and because we're just testing it, right? So let's go ahead and see how we did. So Python 3 and main. All right, it didn't blow up. So we need the sleep method again, since we're now moving the loop into the main.py, since we moved it out of world.py. So we're from time import sleep, and we'll go ahead and do a while true here. And then we also need to remove the import OS from here and remove the os.system clear here, because all that is now being moved into main.py. And this time we'll say from os import system. All right, so while true, clear out the screen. We will call world dot print world. And because how print world is currently written, we still expect it to be passed in world, and we'll be improving this in a moment. So we actually need to do something a little bit goofy and say world.world, right? Now we'll go ahead and say world.step so that we're updating our world with the state of the new world. And we'll go ahead and sleep for our 0.1 second. And let's test that. Uh-oh. I see the issue. This needs to be self dot. Alright, go ahead and try that again. And something's still wrong. What did I do? So the silly thing that I did is I left this print world statement in here. So we'll delete that out. Now we should see what we want to see. There we go. So immediately there's some improvements that I want to make. For example, like I pointed out, passing in world.world here is just silly. So let's go ahead and delete that out. And inside of our world file here, we will delete this. Anywhere that we reference world in here, we'll say self.world because we have that context within our class. Another improvement that I want to make is these 4 lines could easily just be 1 and it's still very readable. So we'll say str world plus equals O if C else dot. And again, I go mixing my quotes. All right. So we can delete that out. Before we go any further, let's make sure we haven't done anything silly. Still looking good. And just while I'm thinking about it, let's format it with black. All right. Now the next easy improvement that we can make is we can delete world here as well, because again, our class has context for the world through itself. So self.world. And we can take this one step further because row count and column count, we don't need to figure those out every single time now because again, we have that information within our own class. So let's actually just fully delete these 2 lines. And where we were saying row count and column count, we will say self.rows. Let's put that there first. And self.columns. And then we now need to reference self.world here when we're appending our list of neighbors. And let's go ahead and reformat that and give it a test. And we made a mistake. Yes, we are now passing in too many parameters to our step method. So we no longer need to pass in self.world here. Give that a shot. And there we go. Very good. All right, so that all looked great, but there's still some improvements I would like to make. The first one that I would like to do is instead of having this print world method, I think it'd be nice if I could just directly print the class. So instead of having print world, let's say __str. So anytime that somebody tries to treat our class as a string, our class now knows how to convert itself to a string. And instead of saying print strWorld, we're now going to return strWorld for the print method. So back in our main method, instead of calling print world, we will instead print world class directly. And this should still work. Yes, lovely. And now the next thing that we can do to make the class look a little easier to use from the end user perspective is instead of having a step method, we can actually just make world directly callable. So let's go back to our world class, and where we have step, we'll change that to __, call. And back into main, and instead of world.step, we'll just call world directly. So now if I had a consumer of my world class, this looks very friendly to use. And the very next thing that I want to address is this looks nice, but I would really prefer this to be a sphere, to really more closely emulate a real world. Programming a sphere is harder than I want to do right now, but what's really easy to do is a toroidal shape or a donut shape, where effectively this edge is going to match up to this edge, this top edge will match up to this bottom edge, and effectively all these corners are pulled together. So let's see what we can do about implementing that. So back in our world class, it signaled to other developers that they probably shouldn't be messing with the get neighbors method, right? So we're going to prefix this with an underscore. And to get our toroidal shape figured out in terms of the logic here, we no longer want to do the bounds checking. So let's go ahead and rip out everything in our if condition here, except we still want to eliminate ourselves from being considered. So we're going to keep that part. And if I've thought about this correctly, instead we are going to use modulo to set our row and column values. So effectively, if we're going out of bounds, the modulo should get us back to the beginning or end of our row or column. So ri equals ri modulo self.rows, and ci equals ci modulo self.columns. And before we go any further, let's see, I don't know what happens when we use negative values in modulo in Python. So let's jump back into a Python shell really quick. Let's test logic that we know works. We've got 24 rows, so we'll do 24 modulo 24, which gives us back to the 0 index, right? And let's say, so we should never have 25 because of how we've got our loops coded with range. So that should be fine. If we do 23, we should still end up with 23, and we do, of course. Now, what I don't know will happen is what happens when we -1 modulo 24. 23. That gives us the last row index of our 2D array. Okay, that's perfect. That's exactly the behavior we want. So for passing in the 0 index to our get neighbors method, it's going to subtract 1, give us -1, and this modulo operator is instead going to give us the last one on our row. So that will work for both the rows and columns because we're doing the same logic on both. Let's actually test this out. So we already made our change. So let's do from world import world w equals world, and let's make our world really tiny, right? So rows equals 5, columns equals 5, just to start. So now let's call w dot get neighbors, and let's do 0, 0. And if we've done our math, if we've done things correctly here, we should still get 8 points back as we established from part 1. So let's see. 1, 2, 3, 4, 5, 6, 7, 8. Great. So now let's do 4, 4. All right. 1, 2, 3, 4, 5, 6, 7, 8. All right, and let's do 2, 2, just a sanity check. It should be fine if the other ones are. Yes, that looks correct. I was a little nervous at first because, the number of falses and trues made the string length different, so they're not lining up, and that's why I got nervous on the second one. But let's test things one step further. Let's bail out of here. Let's put in a little bit of debugging code just to make sure. So we're going to put in a variable. So we'll call this new variable TNI, not TMI, TNI, for temporary neighbor indices. We'll make that a list. And when we do the neighbors append, we'll also do a TNI.append. We'll append a tuple of the row index and column index. And of course, we want to be able to see what's in TNI. So just at the bottom here, I will temporarily print TNI. All right, and it's going to make the output look really messy, but that's all right. It's just temporary debugging sanity checks. So jump back into Python. We will import our world. We will create a new world. This time I'm going to let it be full size. And we're going to say w.get, oh, there's underscore now, get neighbors. And let's start with 0, 0. All right. So 2379, that's correct. 0, 0 is the top left corner, so we need the bottom right corner. We need the bottom left corner, which would be 230, sorry. Oh yes, it's right here, very next one. Bottom right corner would be 7923, or sorry, 2379. Oh yes, 2379, the very first one. And then we want the top right corner. Yes, 079. So our neighbors to the top left corner are the bottom right corner, correct. The bottom left corner, correct. The top right corner, correct. The diagonal, which is the bottom corner one in, correct. One over from us, correct. The spot diagonal up and to the left of us, yes. One row down and directly below, yes. And then the next diagonal, one row down and one over. Okay. And then double check 1, 2, 3, 4, 5, 6, 7, 8. All right. Brilliant. I think we got them all. So let's go ahead and remove our test code, or let's comment it out in case we want it again. And let's run our code and see what happens. Yes, we renamed get neighbors, so we need to go fix that in our call method. All right, should be the only place it is used, so we should be good now. And if we watch this long enough, we should start seeing things bleed over the edge. Yes, we did right here. Looks like we are right here. And let this play out, and then hopefully we'll get one of these alternating patterns overlapping. This one's not alternating, but it's clearly overlapping in a pattern that looks correct. And we do have one that's overlapping here. I'm hoping for one. Oh, we just had, okay. We had one of those guys that crawls across the screen over here and collide with this guy over here. So if you rewind the video, you should be able to see that. So it looks like our toroidal shape is working as desired. So we can go ahead and clean this up now. And you know what? I realized that I never actually set density down where it's used to populate our world. So let's fix that. And I think the last improvement I want to make before I call this a wrap is this is the only place where I'm spelling out the word index. I don't know why I did that. It's driving me crazy. So let's go ahead and clean that up. reformat everything with black and test it again. And just to double check that we haven't done anything silly with our code, let's go back into main.py and let's play with the size of our world. Let's increase it. We've got a little bit of room to play with here. We've got maybe 1, 2, 3, 4, 5, 6, maybe 6, 7 additional rows. Let's see. So rows, we're currently at 24. So let's make them nice, even 30. Columns. You know, we were probably using, not a little less than 2/3 of space, maybe. More than half, less than 2/3. So let's make columns even 100. Let's play with our density as well. Just try to get some visual verification that the density is working as desired. And let's actually decrease the density. Let's set it down to 8, which I think is still large enough to not immediately die out, but visibly smaller than what we had before. Go ahead and run that. And this is why we test. Got an unexpected keyword argument rows. That's because I'm sticking it in the wrong place. There we go. Now, is this actually wider? I don't think it is. Easy thing to do is grab this. And we'll do the length of the string that is that row. Oh, it is 100. Okay, so my eyes are just broken. So let's go ahead and let it run. Ooh, I love these little crawly guys. They've got a name. I don't remember what it is. It's in Wikipedia. Just across the corner there. This is a fantastic test of our toroidal shape, because it's going to miss everything again and then cross down at the bottom, which will prove that all 4 directions work. Cool. For part 3, there's some definite improvements that I want to make. The big one will be all the rules that are currently defined in our call method here. I want to take these and make them individual properties of each critter. That way we can start to manipulate these properties and effectively allow our critters to evolve into maybe they only need one neighbor to live or something along those lines. Another improvement that I want to make is I want to improve our string method here. I want to make it so that we don't have to call clear every single time, or at the very least I want to make it so that we don't have to fully clear out the screen, because one of the things that kind of bugs me about this is, right, like I've lost my scroll back, and part of this is due to how Ghost TTY, Ghosty, tell me in the comments which it is. I don't know. Part of it is how Ghosty handles clearing the screen, I believe. Because in virtually any other terminal, if you scroll up, actually, let me just show you. All right, here's the default terminal for Mac OS. Now, if I cancel this and we scroll up, we'll see that, clear is not exactly clearing the screen. It's mostly just dumping it with a bunch of blank space, right? So if we had commands above our Python command that we wanted to go look at, like, that's lost effectively. Like, it'd be really annoying to get back to that. So I want to improve how we are effectively allowing the animation of Conway's Game of Life to happen. And I think part 3 is going to be the longest of the 3 in this series. Thanks for watching. If you made it this far, you're amazing. Like, comment, subscribe, all the usual YouTube stuff. What's the new catchphrase, the new line? Like that smash button. Yeah, I think that's it. Yeah, like that smash button. And you'll see me on the next one. Thanks.